And welcome everybody to the Daily Space Weather Show. I'm your host, Dan, aka Smash-O-Mash, coming at you as usual from the Smash News Network, least busted name in news, and thanks for tuning in. Congratulations on realizing that the channel exists. That's the past 24 hours on the closest star from SDO. 171 angstroms is the house favorite wavelength. The most activity is in that southwestern limb, which is your lower right of your screen. We've also got some new sunspots in the eastern portion. And let's take a closer look at the second most active region. Down here in the southeast, we have seen a little bit of flaring coming out of that last to rise group down there below the Earth scale. So, flare watch there in the southeast now, as well as in the southwest. So the southwest is the main spot to expect to see a large solar flare. We haven't seen a lot of major changes happening with the sunspot group over there. Sunspot 3599. So there it is. And the solar flare watch in that portion of the closest star will continue for about another 36 to 48 hours. Sunspots are capable of producing large solar flares, even when they are out of sight, having set behind the limb. So don't worry, we've got lots more solar activity for you to show. First, we've also added the 171 angstroms to the colorized magnetogram here, so that's not half bad. Another video, that's just from today. That's not a 24-hour video, that's just today to date. And let's take a brief look at what's going on planet Earth. So you've got the Tinakula volcano in the Solomon Islands is erupting, so that's a new one on the list. That image there by Copernicus. And also you've got Fernandina in the Galapagos Islands producing a volcanic gas plume there. I imagine that's probably sulfur dioxide that is spreading out to the west and southwest. So, let's see what else is erupting here. Abiko is on the list. Also Sakurajima, Dukono, again, Fernandina in the Galapagos Islands. That is indeed sulfur dioxide. Tinakula in the Solomon Islands, Popocatépetl, Sancho Guido, Fuego, and Sabancaya. Moving on to earthquakes. There are the past 90 days as the 7 magnitude earthquake drought continues. Those end in large earthquakes. So, largest quake of the past 24 was in PNG, Papua New Guinea. It was a 6.0 at about 50 kilometers depth. There is a location of that 6 magnitude quake. It happened this afternoon, at least local time for moi. I'm located in Lehigh Valley, Pennsylvania, by the way, if you're wondering. These are the quakes of a 5 and greater magnitude, so things started out with that large quake. It was at 15:13 Universal Time this afternoon. Afghanistan also had a 5.0 less than 15 minutes later. Band AC had a 5.1. And that one was a little over an hour later. So a brief period of quite a lot of unrest there. Keep in mind, any earthquake can be a foreshock. Finally, a 5.8 at Indonesia struck after that. 1856 Universal Time, and then last but not least, a 5.5 in the western Indian Antarctic Ridge. Between the, I guess, the Indian Ocean and the Southern Ocean there, that 5.5 was at 2006 Universal Time. And before we get back to space weather stats, please take a moment to press the like and the subscribe button. Also, please feel free to visit our links. Shout out to Smash staff for optimizing the website, and a quick notice to our Smash Team members. Smashomash.com/Smash Team is where you can get subscription services. And there were some issues that happened with the plugin. So if you're wondering why you haven't been getting email alerts, it's because the plugin died. It does not work with the latest updates of WordPress. So we will get the email alerts back, so don't worry. It was not really our fault that time. The plugin is no longer updated. It's basically an unsupported plugin. So email alerts will come back, Smash Team. And to you new viewers out there, if you want to support the channel, one of the ways you can do it is at smashomash.com/Smash Team. We normally send out email alerts about new videos and about other things, but we're in the process of retooling some stuff. So make sure you check out smashomash.com. We've optimized some stuff, and it is so fast. It's just splentacular. That said, let's take a brief look at Some more solar imagery here. This is, that's 304 plus 335 angstroms. And here's another close-up of sunspot 3599. That is our T-mass, by the way, the most active sunspot of the past 24 hours. Again, the solar flare watch continues for the next, 48 hours. And before we get to things like coronal holes, let's move on to some more space weather stats. The 10.7 centimeter radial flux is now at 131 solar flux units, 131, I think, 128, something like that. 128 solar flux units is the radial flux. And if you're not aware of that, the radial flux comes out of the upper chromosphere and lower corona. The sun's lower nether regions, you could say, they produce a radio signal that is proportional to the sunspot number. So, discovered back in 1947, the radial flux is the most similar data set that we have throughout a solar cycle to sunspot number. So that's what's depicted here. The red line is the sunspot number. The black line is the radial flux, and you can see higher highs and higher lows for the past about 5 months. You can expect to see solar activity continue to ramp up until approximately October of 2024. So you can expect similar amounts of activity for the next about 14 months. So it's going to be an exciting time for space weather. And once again, congratulations for realizing the channel exists. So it's only the world's most comprehensive daily space weather content. No big deal. Here's NOAA's forecast. No geomagnetic storms are in NOAA's forecast. Now, see our previous videos for our forecasts. We don't recap those. We do a video every day for pushing 6 years. So anyway, NOAA's not forecasting any geomagnetic storms or geomagnetic unrests. Make sure you watch yesterday's video. Maybe there's a forecast in there. Who knows? Anyway, here are the last 4 hours of Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. It depicts the last 4 hours of magnetohydrodynamic pressure surrounding planet Earth. It's like 12 Earth diameters. Our Geospace Magnetosphere movie is powered by the space weather modeling framework, which consists of many different variables. Next Earth magnetic moment from the ground for the past 4 hours. And that depicts magnetic flux density at the ground level. You can use it to see the likely places to see auroras, telluric currents, and variations in your ground-based magnetometer. Anyway, things are geomagnetically calm. That's the point. And again, that's the last 4 hours. Our Geospace ground magnetic perturbations map. KP index is at 2. That's a Geospace geomagnetic global average, so to speak. The KP index, an average of global geomagnetism. KP2 is the geomagnetically calm condition we see at the moment. And next we've got some solar wind data here. Here's what the ACE is showing. Quite nominal and quite diffuse. So the solar wind's only at 1.3 protons per cubic centimeter density and under 400 kilometers per second. That's pretty uneventful. And the Discover, a little bit faster and a little bit denser, 431 kilometers a second. Solar wind density here, just over 4.5 protons per cubic centimeter. That's the orange line. Moving on to our GOES magnetometer. There are the past 3 days of magnetometer readings from Earth's outer Van Allen belt. The outer portion of the outer Van Allen belt is where the GOES 16 and GOES 18 complete their geosynchronous near equatorial orbits. Next is our top view ecliptic plane field plot. And Earth is still in a North Pole sector, it looks like. And yes, indeed, you can expect another couple of days for that. North Pole sector shown here in green. South Pole sector is shown in red. Here's our line of sight field plot. A very compact series of data there. That is the last 4 days of solar magnetism, photosphere magnetism in grayscale, solar B field in blue, solar polar fields in red for south and green for north. Which brings us to coronal holes. There's our coronal hole line of sight plot. Once again, the B field here shown in blue, coronal holes in green for North Pole oriented, and red for South Pole. So we are still seeing some serious magnetic indecision down there in that southeastern limb. You can see coronal holes changing from south to North Pole orientation. That's indeed quite interesting. And frankly, if I had more time, I would look into what's going on in the chromosphere in that area. The chromosphere is the layer that is above the photosphere where sunspots occur and below the corona, where most of our SDO imagery comes from. So, there's that. And let's move on to look at coronal holes from SDO. So there you go. There's the last 24 hours from SDO, 211 angstroms wavelength, the optimal wavelength through which to view coronal holes, at least from SDO. And they're pretty minor here at the moment. So let's move on to things like sunspots. I guess those are kind of important for the daily space weather, wouldn't you say? So we'll do that next. And sunspots are currently at about 80 sunspots. We've actually saw a decline today, and I'll explain why here next. We've got some sunspots that aren't counted yet on the eastern limb, like 3 new sunspot groups that are not yet counted. So tomorrow we'll actually see an uptick in the sunspot number, even though that large group, sunspot 3599, and some more associated groups are setting. So we'll see a modest uptick. It'll be almost flat with a minor uptick in sunspot number, assuming sunspots don't rapidly degrade between now and tomorrow's video. Moving on to sunspots here. This is the SDO HMI imagery. So let's see. We've got 1, 2, 3 groups that have not been counted yet, at least. So that's at least 18 more sunspots there. Now, keep in mind some groups are setting there in the southwest as well. So that's going to offset part of that. But it'll be close. It'll be almost flat going into tomorrow's daily space weather video, assuming nothing drastically changes. And things can rapidly change, folks. So, but there's a little bit of a forecast for you. Hopefully that helps. And let's move on to energetic particles and solar flares. So no spikes in the proton flux here. We do have a solar energetic particle watch in effect because we have a high likelihood of large solar flares in that southwestern limb. There's a lot of plasma instability down there, and sunspots close to the limb are the most likely type to produce large solar flares. Here's the X-ray flux over the past 3 days. And we've only had minor C-class intensifications there. Pretty quiet for the past 3 days. And before we cover that, let's take a look at sunspots here from, well, we'll look at oh, this is fantastic. There you go. That's not half bad. And here at the Smash News Network, least busted name in news, we're wholly good. Yeah, wholly good. Spelled W-H-O-L-L-Y. Holy, we are wholly good. Holy cripes, holy crow, Jeebus Gond. That's the past 24 hours. That is 94 angstroms raw imagery along with 131 angstroms 60-minute running difference. They're both ionized iron, ultra-hot ionized iron gas in the solar atmosphere known as the corona. If you'd like to have a closer look, I think we can probably accommodate you on that. There's the equatorial zoom. And let's get even closer, shall we? And there's that southeastern limb. And let's don't forget that southwestern limb. The T-mass, our most active sunspot, sunspot 3599, and the associated groups. Again, plasma instability going on down there right now. And before we go to CMEs, let's move on to a star chart. So this is what's going on over our head. If you want to make your own, try skyandtelescope.org. And you get the moon and Jupiter very close together in tonight's sky. So they're on either side of the ecliptic plane, the largest planet, and Earth's satellite. Next, our solar system forecast. We've got a crescent waxing moon today. That's where things will be in a week. We'll have a gibbous waxing moon by the 20th. And we'll already be in spring by that point. Less than a week till spring. More on that in the meteorology segment. Next, our astronomy photo of the day. And should we switch to full screen? I think we should switch to full screen for this one. It's pretty good. It's not half bad. It's the Seagull Nebula. And it looks like there's actually a pulsar wind nebula in there as well. If you look at this area right here, you can see this feature here. It looks like a bow shock. So that looks like a pulsar wind nebula to me. I'm not sure if that's officially considered to be one or not. It is showing atomic hydrogen there. So it's dominated by that red color. That is hydrogen. I think it's oxygen and blue there toward the center. That would make sense. Keep in mind, oxygen is more massive than hydrogen, and so it has a tendency to stay closer to the star from which it originated. So anyway, again, the Seagull Nebula is the photo of the day. That is also known as NGC 2327 from the new general catalog, apod.nasa.gov if you want to check it out yourself. And let's move on to CMEs. Yes, CMEs. Those are kind of important, right? And it looks like we've got some missing data today, but let's see what we can do. I don't think they're earthly directed. So there are 40 frames from George Mason University. We are seeing some slop on there. It looks like maybe a cosmic ray strike on the aperture, as we didn't have any proton events happening. But sometimes you get a proton event out in space that does not make it to Earth. So keep in mind, folks, at Lagrangian point 1, where the LASCO C2 is located, there is no magnetosphere protecting it. It is just out there in space, hanging out, hoping it doesn't get destroyed. So here is our LASCO coronagraph. You've got C2 and C3. Let's just zoom in a little bit closer here. We've got quite a bit of interference there in the satellite. So now that could be a communication issue. I think that's actually a communication issue from the way it looks. Maybe some packet loss there on the transmission. So that can happen. That can be a result of things like high electron contents. It can just have to do with the location of the satellite with respect to the ground-based station. So there is at least one CME there originating right around noontime today. And let's see if it appears to be earthly directed. I don't think it is, but we'll take a closer look. First through stereo A. So that one, it's coming out of the north, definitely clearly out of the north. And let's take a look at our custom coronagraphs. And they are pretty sweet. So here you go. That is a 24-hour video. There is a comet down there in the lower left. Right in there, you can see that comet showing up and getting pretty dim there, looking like it broke up, disintegrated, vaporized, evaporated, sublimated, whatever you want to say. Turned into gas, most likely. Yeah, so we don't see any plasma motions associated with that CME. Yeah, that's on the far side. So no earthly directed coronal mass ejections, as far as we can tell, based on the imagery we have. No new CMEs headed Earth's direction. Here we've added 193 angstrom 60-minute running difference and subtracted the LASCO C3, the blue coronagraph. And here's a little closer look. And here's an even closer look. And let's move on to plasma filaments. So filaments at Cerro Tololo are looking like this. Cerro Tololo, Chile. There you go. There's a great view of plasma filaments. And we do have some prominences there in the western limb. No surprise there with that sunspot group 3599 setting. So that's pretty sweet. Here's the colorized imagery. And let's do a filament count. Filament count is next. So that's quite a lot of filaments. And let's bring up the last image here and take a brief count. So we've got 1 very dense, 2 very dense, 3 very dense, 4 very dense, 5 very dense, 6, 7, 8, 9, 10, 11, at least 11, maybe 12, maybe 15 filaments on the Earth's side of the disk. The likelihood of coronal mass ejections moving forward is nearly 100%. So, and don't forget to name filaments after living folks if you like. Over on Twitter, x.com/Smashomash. Join us over there to see all kinds of stuff that you won't see anyplace else. It's called exclusive content. We're all over the internet at Smashomash. So if you want to get involved, if you want to share the content on your favorite social media platform, please do. Here are the past couple of hours from the GOES 16 SUVI. The GOES 18 SUVI, I should say, since that's the satellite that it is. And as you can see down there in that southwestern limb, there is a lot of plasma instability going on down there. So that is the stage is set for a large solar flare. Don't be surprised to see an X-class event. It still does have complex magnetic fields in its proximity to the limb, and all of that plasma being as unstable as it is. The stage is set for a possible large flare. We could also see a solar energetic particle event from that. Those are the most likely when the activity is on the western limb. And let's move into our bonus features segment. Satellite charging hazards are first. We've got some minor surface charging hazards there over the northern Indian Ocean region, places like India and the Middle East. Surface charging hazards are caused by low-energy electrons building on the outside of spacecraft. It's unlikely to cause any major communications breakdowns. Electron flux here is still at the highest levels we've seen in months. So that's the past 3 days. And there it is contextualized for you in the past year. So the greater than 2 mega electron volt electron fluence is measured at the F layer of the ionosphere. So those GOES 16 and GOES 18 satellites are way up in the outer portion of the outer Van Allen belt. They're using radiographic measurements to get electron flux for the F layer. So their radiography is how they measure that. Keep in mind they're at like 23,000 miles of altitude. And the electron flux is measured all the way down at the F layer of the ionosphere, which is only 300 kilometers of altitude. There's the forecast model. NOAA is expecting even higher levels. No argument from me there, as I'm out of practice forecasting the electron flux because we've had such low levels for months. Moving right along to the F layer where it's measured. Now we're going to show vibrational frequency. This is not the same thing at all as the X-ray flux. This is just the vibrations of the ionosphere. So here's the ionosonde. Megahertz are millions of vibrations per second. And of course, the ionosphere is characterized by ions. This is literally the bridge between Earth and space. Space weather occurs at the ionosphere and up. Earth weather occurs below that. So, and that's part of the reason why we don't really cover the Schumann resonances. The Schumann resonances are just weak radio signals that bounce around in between the ionosphere and the lithosphere. So that's not very interesting to me in any way because it doesn't really correlate with space weather or Earth weather. It's just kind of irrelevant as far as I'm concerned, so we don't cover it. Anyway, here's the anomaly gram for the ionosphere. That's anomaly in megahertz from a 30-day median. And things are quite nominal at the bridge between Earth and space, meaning it's not very exciting. But we cover it, so you get to see it. Anyway, next, the WHAM, the whole atmosphere model. And don't utter a careless whisper on the electron content when the music dies. Something in your eyes sees the total electron content and the usable radio frequency. I'm never gonna record videos again. Guilty feelings got me not caring. All right, I'll stop doing WHAM renditions into the space weather. No. Here's the latest intensitygram and latest SDO colorized magnetogram. Looks like one more new group just rose over the northeastern limb. Check it out, folks. Another sunspot. Yeah. And just a consumer tip, folks. If you're mad about each sunspot, they're doing great, amazing things at mental institutions nowadays. So if you're mad about each sunspot that forms or grows, consider seeking psychiatric help. And if you've joined a cult, please unjoin said cult. That would be perfect. Now, the countdown to spring. Almost 6 days out. So you've almost survived another winter so far. And congratulations on that. For that, we thank you. Let's look at the stormiest place in the world, or the highest seas at least. So there are the world's highest seas. We've got 38-foot waves down there in the northwestern Atlantic. That is not a great place to be on a boat right now. 38-foot waves, that's pretty nasty. You've also got a 56-mile-per-hour wind there, so that's a pretty serious gale. And look at that, a crazy area of low pressure, making for a bunch of cold water in that part of the Atlantic. Yes, low-pressure systems like hurricanes and so forth make the water at the surface colder. I won't get into it any further, but let's take a look at wind patterns. Also, before I get into anything else, remember folks, since it is the year of the dragon, according to Chinese astrology, make sure you never try to sneak up on one. You might find yourself engulfed in flames. So don't try to sneak up on a dragon in its own lair. That is a huge mistake. It will not work. The dragon might let you in, and it might be because it's hungry. Anyway, these are the surface winds of the eastern world, and check out that low south of Kamchatka. Very strong low there in the northwestern Pacific. Jet streams looking like this. Jet streams of the central world looking like this. Surface winds of Europe, Africa, and the Middle East shown here. Surface winds of the west shown here, and the jet streams of this side of the planet. Doubled up jet stream over North America, if not tripled up. And a strong jet stream there in the northern Atlantic, with a huge divergence there right at Western Europe. It's like the jet stream doesn't want to go over Spain and Portugal. It's splitting in half, blowing warm air up to Ireland and blowing some cold air into northern Africa. Anyway, here's our satellite imagery. Just fantastic imagery here from the GOES Interactive Weather Satellite Suite. Love the visible satellite. You can zoom way in. We've zoomed way out, but we're getting closer and closer to the weather for the lower 48. That's what's going on. And let's move on to precipitation type. Now we've zoomed in on the hot air capital of the world, Colorado. There's lots of hot air coming out of there. There's also some good science coming out of there, but that would be from somebody we don't talk about too much on the channel, Scott McIntosh. Yeah, Scott McIntosh. Shout out to Scott McIntosh. That guy's good. And by the way, you can follow him on Twitter. You'll see occasionally we share his tweets. But anyway, so there's the hot air capital of the world, Colorado, and we've got a mixed bag. A mixed bag of crack cocaine? No. Oh, well, maybe that, but a mixed bag of precipitation there. Part snow, part rain. Is it because the hot air is causing it to be rainy instead of snowy in the eastern part of the state? Well, I wouldn't be surprised. That's our precipitation type map from windy.com. Here's our weather.gov map. And we've got some significant warnings there. If your location is lit up on the map, how about clicking your location at weather.gov? That's too many counties for us to cover. I am unable and or unwilling, or both, to cover that many counties. But there's the map. And here comes some forecasts. The GFS 72-hour pressure and precipitation is first. And snow is going to linger around the hot air capital, dropping some heavy, wet snow on the hot air capital of the world. Next, our accumulated positive snow depth change in inches. And as you can see there, some areas expecting 3 feet of snow, mainly the north-central portion of the state. A lot of other states getting snow in the coming 3 days. 72-hour GFS accumulated positive snow depth change forecast in inches is what we're showing here. And it's all courtesy of tropicaltidbits.com. Next is our temperature anomaly forecast, and we're having some major temperature anomalies here in eastern Pennsylvania, and it is just a delight. It's still winter time, and having temperatures at like 65, 70 degrees is just all right by me. So we'll take those temperature anomalies, and we will give them a massive thumbs up from atop a bicycle. So that's the past 72 hours. That's the 72-hour forecast GFS model. Temperatures are in degrees Celsius, so keep that in mind. Those temperature swings might even be bigger than you expected if you thought those were Fahrenheit degrees, but they're not. Next, lightning. We've got some Gulf of Mexico lightning in the past about 10 hours. Also some North Atlantic and lots of South American lightning. Also some off the coast of Central America. There are our real-time lightning data from lightningmaps.org. And do we have any terrestrial strikes? Looks like we do. Just south of St. Louis, there's a couple of cells down there that are active. Check it out. Hey, Festus, not to be confused with Festivus. There's thunder rolling in. Next time you hear thunder, I highly recommend it. lightningmaps.org. However, if you don't visit the site, I definitely do not care. Next is our Doppler radar. Let me speed things up. There's our Doppler radar map. There's the mixed bag. A mixed bag. Is it a mixed bag of meth rocks? I don't know. Could be a mixed bag of hallucinogenic mushrooms. Here is our satellite imagery. And by the way, this area right here, if you look at this, I'm not going to. No, I've changed my mind. I'm not going to talk about that. I'll just say this. Those aren't chemtrails. That map has a 1 kilometer resolution, by the way. If you zoom in all the way, 1 pixel is 1 kilometer. So just putting those facts out there. Here's a water vapor map. We've got dry air stretching all the way from Baja California to Georgia and South Carolina and beyond. Here's your recap. U.S. Doppler radar depicts vertical motion in the air column from ground-based Doppler radar systems. The visible satellite is satellite-based visible system. So it's basically what you would see if you took a black and white photograph from 23,000 miles of altitude. Last but not least, the water vapor map. It shows the moist air, it shows the dry air, and everything in between. But I'm out of here. So thanks for tuning in. And until tomorrow, may that solar wind be at your back. While I go back to the bunker again, all the stupid stuff I've heard is in the comments again. Aww.